Hello and welcome to 7-2. Today we're going to study using tables to explore equivalent ratios and rates. And I wanted to put this example on our main screen here. So in our first two cells, let me change my color. In our first two cells we have our original rate. So this would, remember with rates, we have like 3 miles per 60 minutes or whatever it might be. So then I would take my original rate, 3 and 60, multiply it by 2 and 2. My original rate, multiply it by 3. My original rate, multiply it by 4 to create my table. Because I know a lot of you might say, oh, well, I'm just adding 3 each time. Well, that doesn't really help us if I wanted to know how many 156 were. You know, then I'd have to add 3 until I get all the way up to that. That would take a long time. So if I just know I'm multiplying it by 3, 2, then that could help us out. Anyways, let's get started on some examples. Mrs. Nelson's class is painting a mural in their classroom. They mixed yellow and blue paint to make the green background. They found that the ratio of the amount of yellow to the amount of blue is 3 to 2. The amount of yellow to blue is 3 yellow, 2 blue. Okay, this is our original ratio. This would just be a ratio. So we're comparing the same paint. Okay. And then they need to make more green paint using the same ratio as before. Use a table to find ratios equivalent to 3 over 2. Okay, so if my original ratio is 3 over 2, I'm going to multiply by 2, multiply by 2. So now I would get 6 and 4. Then I'm going to take my original ratio, multiply by 3, multiply by 3. And I would get 9 and 6. Then my original ratio, and I'd multiply by 4, multiply by 4. So I would get 12 over 8. Okay, and that is all that I need to do. We found equivalent ratios by multiplying the numerator and denominator by the same number. Okay. So now we're going to do kind of the same thing. Our original ratio, I'm going to multiply it by 2, multiply by 3, multiply by 4, multiply by 5. So 4 times 2 is 8, 7 times 2 is 14, 4 times 3 is 12, 7 times 3 is 21, 4 times 4 is 16, 7 times 4 is 28, 4 times 5 is 20, and 7 times 5 is 35. That is how we would fill in our table here. Now, 40 and 16. Why did I pick such a tricky one? Okay, times 2. All right, I can probably do the first two. 40 times 2 is 80. Oh, 120. 160, 200. I just have to add a 0 from my 4 that I did up top. Okay, now 16 times 2 would be 32, 48, 64, and 80. All right, let's try another example. A group of 10 friends in line to see a movie. A group of 10 friends is in a line to see a movie. The table shows how much different groups will pay in all. Predict how much the group of 10 will pay. Okay, so I have 3 will pay 5, 5 will pay 25, 6 will pay 30, 12 will pay 60, and I need to find somebody right here, which would be 10. Okay, well, I am seeing a pattern here. I'm noticing it's almost like $5 per person. 5 times 5 is 25. 6 times 5 is 30. 12 times 60 is that would be times 5. Times 5 is 60. So I'm guessing if I know there are 10 people, I could multiply that by 5 and I would get $50 is how much money they would pay. Another way I could look at it is I have 6, 7, 8, 9, 10, 11, 12. Okay, so I could look at, well, if I'm going up, halfway between these two would be 9. Halfway between 6 and 12 would be 9. Halfway between 30 and 60 would be 45. So if 9 people would cost $45, I would know that I could add $5 to get to 10. But I think the other way was probably a bit easier. Anyways, that is all that I have for you today. We'll be doing a lot more of these type of problems, not just filling in the table with equivalent ratios or rates, because that's very similar to finding equivalent fractions. But we'll be using that information a lot to do real-world problems and check on some problem-solving skills. But anyways, thank you for watching. We'll see you tomorrow.